Hey everybody, welcome to Honors Pre-Calculus. This is a lesson today on vectors. We are again still in Unit 4, and last time we did terminology and notation of vectors, and we found components of a vector, and we found magnitude and direction and magnitude and direction of a vector. So we did all of that. And what we're going to do today is we're going to add and subtract vectors end to end using head to tail, components, and the parallelogram rule. So here is your warm up. I'd like for you to look at the vector u. Vector u, the horizontal component is 2, the vertical component is 4. Please draw and label it on the graph. And then please say what its magnitude is, round your magnitude to 3 decimal places, and state what its direction is. And please round your direction to 3 decimal places. Let's go ahead and pause the video, give it a try. And hopefully you gave it a try and you're done. And we'll review the warm-up. So here is vector u. Just on the graph here, we start at the origin and its head is at 2, 4. So there's vector u. What's its magnitude? So we use the distance formula or Pythagorean theorem, 4 squared plus 2 squared, square root that, we get that the magnitude is 4.472. And again, if you want to use fancy notation for magnitude, you can either state it thus, 4.472, or you can state it thus, 4.472. All right, and then what's its direction? Round to 3 decimal places, inverse tangent of y over x. So that's 64.435. And because our vector terminates in quadrant 1, you don't need to add 180 degrees because 64 degrees is in the correct quadrant. We're all set. Okay, so that's our review for the warm-up. So hopefully everyone did a good job with that. Okay, so today what we're mostly going to talk about is adding vectors and then scalar multiples. So you may need to add 2 vectors together to come up with a third vector. One way to do that is by using the components and adding the components together. So if you have vector u, like we did in our warm-up, 2, 4, and we had vector v, -3, 5, how would you add them together? Well, you can add them together if this is x1 and y1, and this is x2 and y2, you can add them by adding the x's, the x components together, and then adding the y components together. Right? So in this case, the x components for u were 2 plus 2 and -3, so 2 plus -3, that should be -1. Let me fix that. So -1. And then the y components were 4 and 5. So 4 plus 5 is 9. And that's how we would do that. You can also, well, here's one where you could try it, give it a try, see how it goes. Vector A terminates at 2, 4, just like our vector u did. Okay. And so we'll draw that here. And then B, -1, 6. So we'll put that right there. Okay. So if we wanted to add vector A plus vector B, that would be 2 plus -1, 4 plus 6. So that would be 1, 10. So vector A plus vector B would be at 1, 10. So 1, 10. So this is going to be a struggle to make it a straight line, but we'll just do the best we can. So this right here is A plus B. So we have A here, we have B here, and then we have A plus B right there. So that's adding the components. You just add the x's together, add the y's together. All right. There are 2 methods that we would normally do in person using protractors and rulers, but we're virtual, so we're just going to sort of demonstrate it, and you'll practice it a little bit on the homework. But adding vectors with the head to tail method. So you notice that in the examples that we did before, you see how if these two vectors are pointing, this one's pointing sort of northeast, this one's pointing northwest, the sum of the vectors is sort of kind of in the middle of them, okay? If you were to take vector A and move it so that its tail touched the head of vector B and oriented it the same way, it would actually touch the head of vector A plus B. So this is called the head to tail method. We take two vectors, vectors A and B, and place them head to tail. So the head has to be touching the tail, and that drawing a vector from the tail of A to the head of B is actually going to give us vector A plus vector B. Okay, and this says here, it doesn't matter what order we add them, we get the same result. So B plus A is equal to A plus B. Okay, and this image is from Math is Fun. So you can actually look at that if you want in more detail. If you're subtracting one vector from the other, you reverse the vector that you're subtracting. So if you're subtracting B, you'd still place them head to tail, but then you take B and switch it. See how it's reverse direction? You just switch the direction of B, and then you join end to end with the reversed B, and that's going to be your subtracted vector. And then the last method is the parallelogram method. If you added vectors head to tail, so you see how you have this red vector V and then this blue vector U, if you placed it head to tail, which is what this dotted line is, you would get, it's sort of like the last method of head to tail. But the parallelogram method is what this is called, because you don't really move the vectors. You just draw them so that their initial points coincide, right? So that their tails are touching. And then you draw a parallel line from the head of one that's parallel to the other vector, and then a parallel segment to the other vector. And then where they touch is where your vector terminates, right? So the diagonal from the initial point to the opposite vertex of the parallelogram is vector U plus vector V, which is sometimes called the resultant vector. All right. And then the last thing we're going to talk about today is scalar multiples. And this is pretty straightforward. Scalar multiple, we talked about this on our last class. It's a quantity with only magnitude and no direction. When you multiply a vector by a scalar, you can scale its length and magnitude or change its direction if the scalar is negative. So here we have this vector V. 2V is just you multiply the horizontal component and the vertical component both times 2. 1/4 V is multiplying the horizontal and vertical component by 1/4. Negative V, just changing the direction of both components, and then -4/3 V, again multiplying each component by -4/3. So when you think scalar, you just think multiple. You multiply. And we're going to do a couple here. So let's say we have vector U is 3, -2. 3, -2. And we have vector W, which is 4, 5. Okay, let's find V plus W. Well, we can do that. We know how to do that. 3 plus 4 is 7. And then -2 plus 5 is 3, right? So that's okay. We can do that. Negative W. Okay, take W and multiply by -1. So -4, -5. Okay. V minus W, we're going to subtract the components. So 3 minus 4 is -1. -2 minus 5 is -7. So that's V minus W. 3V will multiply each component of V by 3. So 3 times 3 is 9. 3 times -2 is -6. And then we'll do -2W. So -8 and -10, right? So we just multiply with scalar multiples. We just multiply each component by what we're told to multiply by. If we have vector V plus vector W and we're supposed to draw it on the graph, we can do that here. 7, 3, and should terminate right here, right? So that's what we were asked to do there, draw V plus W on the graph. If we think about putting everything together, vector v was at 3, -2. So this was vector v. And then vector w was 4, 5. So 4, 5. Right? So you can kind of see how this works with the parallelogram method, right? If you were to draw a parallelogram from both vectors, since they both start at the origin, you would terminate right where that resultant vector v plus w was, okay? Or you could think about it as if you were to draw a head to tail method, right? You were going to say, okay, well, let me draw vector v from the head of vector w. So vector v, again, we're going right 3 and down 2. That's exactly where our v plus w meets. So you can kind of see how adding using components, adding using head to tail method, and adding using the parallelogram method kind of all ends up having the same result, right? All those 3 methods work to get you the same resultant vector. Okay. All right. I hope that helps. The last thing I want to point out is that on the homework with number 6, because I saw some people having a hard time with this, this is a diagram for number 6. That angle that says 55 degrees, that's 55 degrees from here, from this axis. So it's really 270 degrees plus 55 degrees, which would be 325 degrees. So just be careful with that. Okay. All right. That is everything that we learned on this day. I hope you all have a great evening, and I will talk to you soon. Thank you for watching.